All right, so let's take a look at what y'all are going to do in this lab. So first it introduces what a counter is, and a counter, all it is a sequential circuit that goes through a sequence of states. So it doesn't necessarily have to count in like any pattern that you can think of. It's just going through a sequence of states, and it can be synchronous or asynchronous. And you define a counter both by how many states it has in its cycle, and you also whether it's consecutive or not, if it's like an up counter or a down counter or not any of those things. But it's basically goes through a series, and most computer counters, when they get to the end of their count, they wrap back around and go back to the beginning. You also have the 7-segment display, and we'll talk about that in a little bit. It has two parts. It has both the part where you say which segments are going to be lit up, and also the part where you tell it which display you're going to use. And we'll go over all of those, and we'll go over how to assign them. And then the case statement, we've used a case statement before, or I have in here, so if you've come to my sessions, you know what those are. And case statement, like an if statement, needs to be inside an always block. Anything that you're changing inside of it needs to be a register variable. So you need to define things that are inside the always block as reg, and anything inside a case statement is also going to be, case statement has to be inside an always block, and so it's going to be a reg. And so what your lab is going to be is to have a synchronous 3-bit counter with an enable input. So the enable and the clock signals are the only inputs, and it's supposed to loop through this sequence, 6 3 1 2 4 0 5, and then go back to 6 6 3 1. I say that? It doesn't say that, but surely it is. Yeah, it's got to be. Okay. All right. And that's what you're going to do. So let's talk about the different parts of this. So first, let's talk about the counter. Okay, so when I've talked about counters in the past, students have always worried about, so I'm going to do just like a 2-bit counter. So a 2-bit counter be 0 0 0 1 1 0 1 1. That's if it counts in order. And students who have made a counter like this before always worry about like an if statement. It's like, well, what if it gets to the end, then you have to tell it to go back to the beginning. But you don't, because what is 0 0 plus 1? I have a 2-bit variable. So my variable, I can have my variable x is 2 bits. So output reg 10 x. Okay, so, and I start off with x equaling 0 0. And then I add 1 to it. What do I get? 0 1. Okay, now I add 1, so this is now x. Now I make x equal to x plus 1, and what is x? 1 0. Now I make x equal to x plus 1, and what is x? Now I make x equal to x plus 1, so what is x? 0 0, because it's a 2-bit number. And so you don't have to say, well, what do you do when it gets to the end? You don't need any if statement. So if I had a 2-bit counter, all I would have to do is say, so if enable, so if I'm like have the enable one, then at whatever clock cycle I had. So like, let's say this was always at positive edge of the clock, then x would equal x plus 1, and that'd be it. That's all you have to do. That makes a counter. Okay, so how are we going to make a counter that counts in some crazy sequence? I'm not going to do the sequence that y'all had. I'll just make one up. Let's say I have 5, 3, 1, 0, 4, 6. That's the sequence I want to count in. And I want to do this as 8, 6, 7, 5, 3, 6, 7, 5, 3, 4. That's going to be my sequence. 8, 6, 7, 5, 3, 4. How am I going to make it count? I want to do this as efficiently and as easily as possible. First of all, how is my specifications for this program, how do I know what number I'm displaying? Or how do I know what number I'm at? And how does the TA, or the TA says, show me your count sequence, how does the TA know that you're on the right number? It shows the number on the 7-segment display. Does the 7-segment display, the number that it shows, does it have anything to do with a number? It's just whichever bits you light up. Is there any reason why these things have to be associated with the number that they are? Like, for instance, couldn't I make, how many flip-flops would I need to have this many states? So if each of these is a state, how many flip-flops do I need?
Oh.
I have 7 states. 3. So I need 3 flip-flops. So this would be a 3-bit counter. Okay. I will be really surprised if I get through the session and at least one person doesn't ask me about why. Well, I can't explain it yet, but we'll see in a second. So I'm going to let 8 correspond to the 3-bit binary number 000. And I'm going to let 6 be 3B001. And 7 be 3B010. And 8 be 3B011. 5. And 3 is going to be 3B100. And 0 is going to be 3B0101. And 4 is going to be 3B110. I notice at this point I didn't use up all of my different values, so when I do my case statement, if I do a case statement, I'm going to have a default. But notice that this number doesn't correspond to this number because these are just states. They're not really numbers. So I think the easiest thing to do is to make them parameters. And if you do them in order, it'll make your counter 10 times easier because then your counter only has to count. You only have to add 1. You don't have to do a case statement and an if each time for the counting. You'll still have to do a case statement for your display. But so what I would do with this is I would have as a parameter 8 equals, and the word 8, 3B000.
Can't be a number.
Can't be a number. 6 equals 3B001. 7 equals 3B010, and so forth. Okay, so then, if we did that, let's think about what our code is going to look like. So if you have your computer and you would like to go ahead and get started on working on some of this, if you wanted to do write some code to look at it, let's see. You can go to EDA Playground. And let's think about what all we would need, and we'll work on this together. I'm going to do not y'all's lab. If you want to be filling yours in with your own stuff, you could do that. So I'll do Module Lab 8. And what are our inputs and outputs?
And clock.
Say it again.
Enable and clock.
Enable, clock, and our output, I call the output seg because then I don't have to rename the things in the constraint file. Yeah.
Is there any chance you can like zoom in on the?
Yes, absolutely. Thank you for asking. We have to have one other output because I forgot to mention this. We have to have one other output, and that's AN, because that is required to make the 7-segment display work. And actually, well, we'll go ahead and start the code, and then we'll come back and fill in the part about the 7-segment display. Okay, so our inputs are enable and clock. And output reg. Now I always do my 7-segment display. I actually do an 8-segment display because I put the decimal point in because I don't like the decimal point on my board always seems to light up and it just bothers me. So I put in the last one. So I do so this would actually be 07. If you only do the 7 segments, it'd be 06. And it's the one time that I do it in that order, seg. It matches up with the way I think about it. Yeah. And then we'll have output reg 30 AN. And all this one does is going to tell you which display it's going to be on. And then you'll need, because this is a finite state machine, you'll need a current state and a next state. So these will be just reg. And we needed 3 flip-flops, so it'll be 2, 0. Current state. And I'm putting them in 2 separate lines because with my test bench, sometimes it's useful to make current state and output so I can see what the state is. It's not actually going to be an output on your machine, but for a test bench, it might be useful to debug to see if it's in the right state. And so I'm just not putting them together. I'm also going to initialize it and say that my current state is going to start at 3B, 8675309. Oh, it's 000. And reg next state.
Hey, can we change the last number to 9 instead of 4?
Thank you. I have the wrong number, don't I? 309. Yeah. Wow. Okay. That's me for you. Yep. Okay. All right.
School up.
It'll get my video banned from YouTube.
Okay, you're gonna be blocked.
I know. It'll be a copyright infringement.
Someone bought the number. No.
I feel sorry for them.
Usually whenever you call them, like you call that number, it starts playing the song. Like, yeah, I'm being serious. But
Yeah, there was like, have y'all ever been to Universal Studios in Orlando? You ever been on the Spider-Man ride? There's a phone number on the wall in there. It's like, call this, and if you actually call it, you get Spider-Man on the phone. It's kind of cool.
Oh, it's fine.
Yeah.
I want to meet this brother, man. Where's that number?
Now, it doesn't do any good if you don't put these in order. If you don't put these in order, which you don't have to, but if you don't put them in order, then you can't take the easy way with the counter.
I tried to do this and I was trying to do it like the book did it. And it didn't.
Oh, yeah, I'm not doing it the way the book does it. It's a good book. I mean, that's how I learned everything, is I read the book.
I still like the examples of so far away from like figures.
That's what it's on the second
So for the second segment one, it's using an 8-bit at Bricks like 5110 and 100.
Yep.
This doesn't really apply to us. We do have to look into 8-bit.
Yeah, no, you can do a seven bit. So what I do is I will show you. Let me get the constraints. So that I'm not going in order here. So this is not something that you can test out with a test bench, the constraints. So I have this, the constraints file in the SI resources. If you see it, it's oops. Constraints. Or is it constraints.v? Can't remember. Yeah, this is the one I want. Okay, so what you will want from the constraints is you will want the clock signal, and we'll set that to, actually we set it to something different if you use the button clock.
Can we just copy that if we had that?
Yeah, I just don't have it. I don't have it handy. I'll open up Vivado so I can get it. I don't know how it's pronounced. Does anyone know how it's pronounced?
I could care less.
Okay, so you'll need the clock signal, whichever one it is. You'll need one switch for the enable. So you'll just pick a switch, and whichever switch you pick, you would change that to enable. And then you'll go to your 7-segment display. And notice beneath the seg 0, 1, 2, 3, 4, 5, 6, there's the DP. I changed that one to seg 7. And that's why mine is an 8-segment display. Mine is better because it has 8 segments. And so that makes it work. But you don't have to do that. You can just use the first, you can just use the 7. So you would uncomment all of these. And then also underneath the 7-segment display is the AN, and you need those as well, so you would uncomment those. And that's the one that chooses which of the 7-segment displays it goes on to, because there's 4 of them. But you have to have all 4 of these to pick one of them. It's kind of weird. It's not like you can just have, pick one that you want. And these are all active low, and so you'll set the ones that you don't want to use equal to 1, and the one that you do want to use equal to 0. Okay, so now if I go to Vivado, tomato. So from my constraints, I just wanted to get the clock part, which is this part. Okay, so now if I go back here, and I set this as Notepad++. If I tell it I'm using Verilog, it doesn't do much because they're the constraints. So I only need one of the switches, so I can get rid of all the rest of the switches. Don't need the LEDs. I do need the 7-segment display. My 8, just, And then, if you use a different button than the external button, you might, if you use one of those buttons, you would have that. Or if you use a switch, you have to use something for the clock. And so that would be what you would need for the constraints. And so it's strictly laziness that I use the name seg and AN, just because here they are.
That's efficiency.
That's right, it's efficiency, it's not laziness. Okay, so those will be your constraints, and there's you can't really test those that well without the board. But let's go back to the code that we can test, and let's think about what we would need in here to have it count. So we know it's a finite state machine. We know we're going to have at least 2 always blocks. At least 2. You might have more than 2. In our case, I think we're probably going to have more than 2. So one of them is going to be always at positive edge of the clock. And you can choose where you put the enable part. You could put the enable part in the block where you're choosing what the next state is, or you could put it in this second always block. I like to put it in the second always block because the second always block is the one that actually advances. The second always block is the one that you press the clock and it does the next thing. To me, that's where the enable belongs. That if you're not enabled, it shouldn't do anything here. So I like to put it here sometimes. So I'm going to put begin, and I will have if enable next state becomes equal to current state. And end. I didn't actually need begin and end there because the only thing I have in there is a single if statement, but you never know, I might end up needing to put something else in there later. So I just went ahead and put the begin and end. Now we need to have an always block for our counter. Now, people struggle a lot with what to put in this list, because you don't want this to only be at the positive edge of the clock. At the positive edge of the clock, you need it to already know what the next state is going to be. And I find the thing that works well in here is always at star, because this is saying just recompute this all the time. Just always be looking, because it's not really going to do anything until you have the positive edge of the clock. And so no matter what kind of finite state machine you have, this means it's always going to be looking to see what the next state is going to be. Nothing's going to happen unless you set something to happen in here. And I don't like to do that. I like this to all be figuring out what's going to happen. And then it'll actually happen over here. So just always at star. And then what are we going to put in here to make it count? So we haven't done the 7 segment yet, but what are we going to do to make it count?
States in.
So the I'm going to have an if, but we'll come back to this in a second. This part's going to be in an else. Next state is going to become equal to current state plus 1, because I'm just going to advance. Now, I showed y'all before with that 2-bit that you didn't need any ifs. And I said students always want to put an if in there. And now I'm putting an if in here. Why do I need an if for this one? What would happen after 8675309? It would go to a state that doesn't exist. And so I actually do need to put this in here. So I need to have if current state equals 9. You could either put 9 or you could put 110. Then what should the next state be?
like line up at 8.
Yeah. I am going to put a begin here and an end.
This next state. Wait. Oh, never mind. That was worse than
Okay, so I am curious to see if this works. Now, it's hard to tell if it works because right now I don't have any outputs. And so just to see if this works, what time do we have? 4:20. Just to see if this works, I'm going to change current state to an output. And come over here. And I'm gonna make a test bench where we're gonna try this out and see if it works. And so for my test bench, anything that was an input is gonna be a reg. And anything that is an output is going to be a wire. Actually, since I'm not using the display yet, I'm just going to comment these out, and I'll come back and put these in. And just right now we won't use them, so I'll put. So right now, current state is my only output. I'm just trying to figure out, I don't know what they're talking about, and I feel very left out.
We're talking about Lent and how there's still 3 weeks left.
Ah, Lent, and there is still 3 weeks left, yes. Okay, so now what I need to do is I need to tell it the name of my module, which is Lab 8. And I need to put in it the same order, enable, clock, and current state. Let's wait and see if it works, and then you might want to write it down because you might use it to test it. Actually, I don't put this in here. I put Lab 8, and then I give it another name. So this will be like my test module. And then I'm going to do initial begin. And the first thing I want to do is I want to make enable equal to 1 because I need things to be enabled. And every time I change a value, I need to give it a little bit of a delay. So that's the hashtag 50. And then I'm going to display in quotes %B, comma, current state. And right now the current state should be 0 because that's how I have it set to start. Now, how do I make the clock have a positive edge? I make clock equals 0. and then I make clock equal to 1. But I do put in my little delay, and then I'm going to do some cutting and pasting. Clock equals 1, 50, and then I will display my current state again. So actually, I just want to repeat this. How many times do I need to repeat it to see if I get through the whole cycle?
8, 7.
Actually, I'm going to not copy and paste because in case I have a syntax error, so I don't have to go correct it a bunch of times. Let me do this first. And did I end my module over here? No. Okay. So I just did it a couple times in case I made some mistakes, I can find them. And then you can pick over on the side, if I could scroll over to the side. Who made me make the screen bigger?
It's on my fault.
Ah! Why can't I scroll at all? Over on the side, I have to pick a tool. I have to pick a simulator, and I can't get my screen to get any smaller. I can't. It's not working.
The control Z is not working. Or the control, not control Z, control minus.
It's working, but it's not. I can't.
It's just physically zooming it out rather than.
Right. It's not.
The side tab?
Yeah. It should, yeah, it should like just, you know.
It's like it's only expanding over on the right. Okay, and I can't even go down and save it. So I want to save it, but it's not. I can't give it a name because I can't go down to give it a name.
Try it. Actually, it might have been because of that pop-up.
It was. It was. It was. Okay, so I need to choose a simulator. I'm logged in with a university account, so I can use a paid-for one, which gives me a little more information. So I'm using Alltech Riviera. If you are if you're not logged in, you can use Icarus Verilog. Is a good free one. And I'm going to, before I forget, I'm going to save this. So Lab 8B.
Oh, so we'll be able to run it? Is this saved publicly?
I don't know that I have it shared, but yeah, I mean, I'm happy to share it.
Public, anyone with the link can view it.
So when I run it, and now I'm trying to get to the, here we go. Okay, syntax error, test bench, line 7, line 9. Okay, so it's telling me, so this would be useful to know how to do, is to how to, to read your error messages. So it's telling me in my design, I've got a syntax error on line 7, and in my test bench, I've got an error on lines 1 and 4. So line 7, so I think it says I have a period in here somewhere. Does anyone see?
You have, like 0 and 9, you have it spaced out while the others aren't.
I'm missing my B here. Okay, and then,
They're up in the air.
oh, forgot module. Module. Okay, so now let me save and try to run again. And test bench line 18.
He's a senior. He is a senior.
Somehow this got, oh,
Oh,
enable lab 8, test module, enable clock current state, initial begin.
You don't have to put next state?
you can do like SATCOM stuff.
No, I don't need next state in my test bench.
And what I do is go copy so if you can lock in
So it doesn't like my end. You don't need it for lab. It is good to know how to do though. Initial begin.
Hey, dude, somebody got good at this.
It's like the missile thing. It makes it
So you want that?
What is good about like
Full benefits, paycheck, my family is good. I literally like had like and you get a reputation like it's really easy to team. Let's say you start out lucky, but oh you worked at first round. Literally, basically it's your fucking day. It's not like I'm stable lucky for the rest of the time. It's a good. Okay, I won't say that.
I'll do anything for my high 100K. I am 100K. I'll do anything for money.
Dude, I'm literally like flash fires my ratings for this year. They literally communication.
Let me see.
Nothing like that. And, but yeah, they're like, they work in like project management. It's like, yeah, they're big, dude. That's
Project management is crazy.
not, they, t-shirt on everyone. I just started seeing this everyone. It's horrifying.
Yeah, that's what I like. I'm looking so diverse. Not because it's the only internship I could get.
Yeah, and things go, if I don't, things go well, I might end up being his underling.
Yeah.
Okay, does anybody see anything different with this one that does work? It's got the time scale, it's got initial begin, it's got end module.
So I have a question.
Yes,
I don't know what's going on. So
well, yeah, it's also because no one's listening to me, but that's okay.
Oh, yeah, I'm
it's
sorry.
so sad. I'm sorry.
Yeah. What was your question, that you don't know what's going on?
No. My question was, why do you have the number 50 and?
Okay, can someone answer that question?
It's just a delay. That's a delay.
Because this is supposed to be simulating actual hardware, and so that's telling it how long to delay. And so I'm wondering if the problem is that I didn't tell it what our time scale is. And so it's saying to delay for 50 nanoseconds, and if you don't do that, it doesn't work because it doesn't have enough time.
Could we just, instead of using the hashtag 50s, just slow down the timescale clock speed at the start? So go from one, I don't know what that's, nanosecond to like 30?
1 nanosecond to 1 picosecond. I don't think that works. You're welcome to try it. I have never tried it.
What is that ratio? It's 1 nanosecond to 1 picosecond.
I don't know. It's just what I copy it from other labs and put it in.
And then the percent B.
Percent B. Can anyone answer that one? So it's displaying, it's a placeholder. The percent is a placeholder for a variable, and the B is saying it's display the value in binary, and then after the quotation marks is the variable name.
Okay. I'm trying to see if I got it over.
Yeah, I would love more questions. Still can't figure out why it's telling me I'm not matched up with my begin and
Does it
ends.
still give you the 1-7 error?
Yep. So here's the other one. Nope, that's the same one.
What error are they giving you?
Well, let's run it and we'll look at the error. So the error they're telling me is, well, make sure it's in the test bench. Maybe it's not in the test bench. It is in the test bench, and it's saying it's an end module pair mismatch. And so that's acting as if I started the module and I didn't end the module. So it's like, and I don't see that because I've got a module and I've got an end module and I've got a begin and an end. So I'm pulling up my other one that does work to see if I can see what the difference is. So Lab 8 test bench, reg enable clock, wire, Lab 8 unit under test, initial begin, a lot of stuff, end semicolon? Did I not put a semicolon? I didn't put a semicolon
For what?
Where?
after end. Okay, I don't want to waste any more of your time. I don't see, Nobody else has another idea?
Verilog, I get angry at because it doesn't tell you where you went wrong, so.
Well, it's telling me, it just doesn't help me because that doesn't seem to be the mistake.
And colon, semicolon, do we have to put the semicolon?
No, usually not. Usually not.
Yeah, so,
It says missing test match.
What it's saying is syntax error, unexpected token end.
Is there a big-
What's the second one?
is there a semicolon for the module?
I don't believe there's one on end mod.
I'm in a module,
Yeah, there is. I make that mistake a lot.
Does it work if you disable the 50 delay?
No. You mean just take out all the 50s? No.
Yeah, I
No.
wonder if you just
No.
disable it.
Everybody always wants me to take out the delays, but that's not the problem.
Oh, could you eliminate this down, cut this down to 2 states, so we only know, like, so we don't have as much stuff that could be wrong?
Yep.
Was it that you didn't have a begin? And you
No,
had-
I had the begin before, so I don't know what it was. Because now if I add this back, no, you don't have to change enable more than once. So I'm missing. I must be missing a semicolon somewhere. Clock equals 0, clock equals 1, display current state, clock equals. So it likes that. So clock equals 0, clock equals 1. It's fine with that. Display percent B. Is anybody else try it? I mean,
Mine's just getting ZZZ like it's just.
But that's good. At least it's running. And so we can troubleshoot that. Okay, 0, 0, 0.
So I put, I had semicolons on the 50s.
Yeah, sometimes I do and sometimes I don't. And so,
Yeah, so that was
So you're getting 0, 0, 0?
mm-hmm. Okay, so it's not counting. So let's see if we can figure out why it's not counting.
And just double check, so that second body of code is to simulate the code running into the, or being executed by the circuit.
Yes, so what this does, okay, so that's, the question is, basically the question is what is going on? And so here's what is going on. It is saying this line right here says, run that module over there in the other window. And when you run that module, give it these values right here. Make enable equal to 1 and then wait 50 nanoseconds. And then just display this value for me. And then all of these clock equals 0, so make clock equal 0, equal 0, and then make clock equal 1, and then display the values for me again. And so it should be displaying the values of the current state after a positive clock edge. So it should be counting.
And so will we see that in the terminal output at the bottom? Like the string of characters?
I think this was, somebody told me this and I wasn't listening. This is current state. Here's my problem. Current state becomes equal to next state. That is highly important. I was never changing the current state. Okay, and so you were asking about at the bottom?
Yeah.
So that is showing me these display, the $ display, those are the print statements. And so it's saying it was originally 0, and then it's saying, well, I don't know what it is anymore. So it's getting the XXX. And so that means it's not necessarily changing when it should be changing. So let me try. That. And a lot of times I find that my problem is just there's not enough of a delay. I feel like there is, though. It should be enough. Because my other one was working. We'll see what the difference is. This is always at star. If current next state becomes equal to 8, next state equals current state plus 1. Current state equals 9, next state equals, okay, so if current state does not equal 9,
Do you have to specify, like, if you just do +1, will it just increment it by 1? And it doesn't, you don't need to specify this boolean, or not boolean.
no, I don't have to do I don't. It knows, it knows what 1 is. It does know that. Okay, so let's see if we can see what the difference is between the one that I very carefully got working before the session so that I would not be up here and not have something not working, because I wanted to make sure that I knew what I was doing. So let's see. Okay, so I have always at begin if enable. So I have an enable, I put my enable up here. If current state equals that, the next state is 6, else next state equals current state plus 1. That's the counter. Always at star begin. Always at positive edge of clock, current state equals next state. Clock equals 0, a delay, clock equals 1, a delay, and then a display. So this one, when I run it, you can see this is the current state right here. You can see how it's counting.
And that other number is the included values to display.
The other one, that's the 7-segment display. That's the 7-segment display, which we will get to. We'll just go ahead and get to it. So, okay. So, how would you do the 7-segment display? It's another always block. with a case statement.
And it's active low, so.
Oh, so I would also have to have on here, at some point, I would have to say which, and I could just do this right here. I don't even have AN in this one. So you'd have to say AN equals, so let's talk about what those are. Okay, so your 7-segment display. This is segment 0, 1, 2, 3, 4, 5, 6, and then the decimal point is 7. And so those are seg 0, seg 1, seg 2, and so forth up to seg 6. And so whichever ones you want to be lit up, you make those equal to 0. So if I wanted to make the number 3, then I would make seg equal to the 7-bit binary number 0, 0, 0, 0, 1, 1, 0. Because I wanted this one, this one, this one, this one, and this one. And when I look at my 7-segment, 0, 1, 2, 3, 4, 5, 6. So I wanted 0, 1, 2, 3, and 6, and the others are going to be 1. And then AN, you make that equal to the 4-bit number 1110 if you want it to display on display 0, and 1101 if you want it to display on 1, and 1011 if you want it to display on 2, and 0111 if you wanted to display it on 3. So you could, if you wanted to, so like if I had my additional, so on this one, I don't have my AN on this one. I could just have AN and output reg 30 AN, and then I could have begin and end, and I could set AN equal to 4B0111, and then it would always display on display 3. If you wanted to have a display on different displays for the different numbers, then for each of these, you would have a begin, and you would have an end, and then you would also set AN here. And so you could do that if you wanted to.
Make it move like as it's going.
Yeah. So you can make it like go across, so you could do. But that would mean you have to put a begin and an end on each one of these. And so forth. Make sure that you put the default in on your case statement, because you don't have a value for all. You only have 7 numbers in your counting sequence, so you do need to make sure you put the default in there. And so what this test bench does, if you look, I had it display the segment and the current state. Now, the current state is not really an output. That was just for debugging to see if it was counting. And it turned out to be useful because it wasn't counting. Did we figure out why it wasn't counting? We didn't figure out why it wasn't counting. Let's see if we can figure that out real quick before we go.
Yeah, it wasn't like that?
No, this one, the one that I did before counted, but the one that I typed while we were here together was not counting. Current state equals, do I have a 9 up here? Yeah. Maybe,
So the first one is 0 and then
the first one is 0 because I initialized it. I initialized it to be 0 right here. It's all about the timing. Nope, it's not all about the timing.
did you have the asterisk thing at the in the always block initially?
Yep. Do I have things in the right order? Enable clock current state. Enable clock current state. Yeah, I don't know. Okay. So I have to go, and y'all have to go. I do. It is working on the other one, so I do not know why it is not working here.
Between the, so on this one, we didn't have a long case statement,
Right?
but on the other one we did. Do I need to add that case statement?
You will if you want to have a seven segment display.
Okay.
Yep.
And then, so my only question was on, like, the segment. Like, you explained it in OneNote, like, why you had certain digits of 1 and certain at 0. I didn't really
You didn't understand that part?
No.
Okay, I'm still recording, so, so here's how it works. So they're just defined based on this. This is 0, 1, 2, 3, 4, 5, 6. And so you have your number that I'm calling seg equals this number is 0, 1, 2, 3, 4, 5, 6. And then if you make like the number 4, you see which ones you want lit up. So you would want lit up this one, this one, this one, this one, and this one. So the display for 4, you would have seg equals 7b, and then 0, 1, 2, 3, 4, 5, 6. You would want a 0 and 0, 0, 1, 2, 3, 4, 5, 6. So you'd want a 0 and 0, 1, 2, 5, and 6, and 1s in the others.
Okay, and this is for what number?
That was for the number 4.
Okay, so why does 3 get lit up too? Is it because it's touching like 4 in it or?
Okay, so this has nothing to do with numbers. The numbers are labels.
Okay.
This is labeled 0. This is labeled 1.
Okay.
This is labeled 2, 3, 4, 5, and 6. And so I decide what my number looks like. 5 looks like this. So which segments do I need? I need this
okay.
one, this
Okay, I
one,
see
this
it now.
one,
I see
this
it now.
one, and this one. And so that means I want digits 0,
5,
5,
6, 2, 3, all with
6,
a 1.
2, and 3 with a 0. It's active low.
Oh, okay. Okay.
So it's 0, 1, 2, 3, 4, 5, 6. So this would be 0 and 0, 5, 6, 2, and 3, and 1's in the other place.
Thank
All
you.
those other
Okay,
guys.
that makes sense. Okay.
And that's going to be what you have in a case statement like this.
Got my test back. I don't think. No, wait, I didn't.
Test back for what?
I digital one.
Yes, you did. Yeah, you did, because you were like,
Thank you.
Oh, you're welcome.
Well, I need coffee. That's my excuse.
oh. Well, you have to
Okay,
wait.
that
3
makes
months
sense.
there.
That's
2 weeks.
what I was
Just 3
missing.
weeks.
So
I
in
keep
your,
up with those things.
you'll have another always block where you're going to have a case statement, and the case is going to be based on whatever state it is. You're going to say what that value is going to be.
Okay.
You also are going to tell it, you could either tell it once for the entire thing that you're only using one display,
Thanks.
or you could have it be on a different display each time.
Okay. Okay, that makes sense. Thank you.
Okay, you're welcome.